This is a knife-edge galaxy. Its edge is literally facing us. It's bigger than the Milky Way and has a super cool recent supernova and so much more. So I guess one way to describe this galaxy is like a piece of paper and angling the edge towards you. By the way, guys, sorry, I'm kind of sick. So welcome back to DivScope. This video is on the galaxy NGC 5907/5906. You have previously watched the intro, and now this part of the video is chapter 1, where I talk about how I made my own images of the galaxy. Chapter 2 is any kind of data. This includes position, distance, etc. And chapter 3 is more details. So I have this image. Looks pretty cool. I use mosaic mode at 1.5 times. My goal is to crop in and remove the rotation artifacts. Turns out I should have done more research because I didn't even need that. Mosaic mode works differently than normal capturing, so I don't need to actually crop in because there are no rotation artifacts, at least for the amount of time I captured. Kind of captured a little too wide, but I think it's okay. This is a picture with astronomy.net. It's this website where you can upload an image and it tells you what objects are in the image. Next up, I have this image, which is an AI enhancement image, a C-star feature that combines denoising, dynamic background extraction, brightness, contrast, saturation changes, and also star reduction. I also made my own edit of the image in Affinity Photo, so yeah, here's what that looks like. Okay, next up is NGC 5906, the data for it. I'll discuss why I said NGC 5906-5907 later. Megaparsecs equal 32.6 million light years and are based on 1 parsec, which is a unit for distance in astronomy. 1 parsec is 3.26 light years. Distance for galaxies that are really far away is quite hard. One of the methods used is the TF method. So measuring the redshift based on the galaxy's properties, rotation, etc. And then another redshift method is calculating the redshift based on the universe's expansion rate. Redshift, basically, light from space objects gets more and more red, lower in energy because of the universe expansion, so redshift is useful for measuring distance. So there's a couple measurements. The measurement with the lowest margin of error is 17.05 to 17.23 megaparsecs from us. But no method was listed and is from 2013. The most recent has a much larger margin of error, so I'm not going to tell you that one. This galaxy is probably between 45 and 56 million light years from us. Maybe in the future we'll be able to find better ways to measure stuff. Here's the table, by the way, if you want to analyze it. The galaxy is moving away at 667 kilometers per second. By the way, if you look at the data table, those values that are really small, they just give the actual redshift and you have to multiply it by the speed of light. The RA is the left position in the sky, and it is 15 hours, 15 minutes, and 53.2397 seconds to the right. And the declination is 56 degrees, 19 arc minutes, and 47.568 arc seconds. Declination is the up and down position, so the measurement I just described is up. It has an apparent magnitude, which is how bright something appears to us, of 11.1. If you're curious, the sun is negative 27. For apparent magnitude, the lower is brighter. Okay, first off, this galaxy is called NGC 5906/5907. Why? Well, because astronomers kind of just measure different parts of things. William Herschel found the east part of NGC 5907 in 1788, and George Johnstone Stornery found the left part in 1850, NGC 5906. When the NGC catalog was developed, they were labeled as two separate parts, but they're part of the same galaxy. This galaxy is known as the knife-edge spiral galaxy, as I said earlier, because the edge of this galaxy faces us and it's a spiral galaxy. Oh yeah, there's like a super recent supernova in this galaxy. I'm talking 3 months ago. It's discovered by Yazaro, and it is a Type 2 supernova. So by a star at least 8 times the mass of our sun exploding at the end of its life. It's called SN 2026 KID. SN 1940A was a Type 2L supernova, meaning the brightness got lower over time linearly. And there was also a ring of gas around NGC 5 from another galaxy which it consumed, and also streams of stars and dust that extend beyond NGC 5907. These streams have less heavy elements. Iron and anything with a bigger atomic number is considered a heavy element. So the number of heavy elements is like 50% of our sun, which is not too bad for a stream of stars. Because of the metal and a few other factors, it is most likely a galaxy collision rather than NGC 5907 dominating and just consuming the other galaxy. The other galaxy is probably not more than 8 times smaller than NGC 5907. These stellar streams extend about 150,000 light years from the galaxy, and if the collision is true, then it occurred about 4 billion years ago. ULX stands for ultraluminous X-ray source because it emits X-rays and it's bright. So NGC 5907 ULX1 is a ULX in NGC 5907. You can tell by the name. It's a pulsar, which is a fast-spinning neutron star, which is a type of star that can form when a big star dies. The pulsar emits X-rays. It's also a binary, and the other companion is probably a red dwarf. We don't know for sure. But the energy is about 10 to the 34 watts. Your outlet is like 1800, by the way. A red dwarf definitely could provide that energy, and it's not enough that the neutron star could collapse due to neutron degeneracy pressure. Last is polyatric aromatic hydrocarbons, definitely pronounced that wrong. These molecules absorb UV light and emit light back. In NGC 5907, they spread through the halo and disk more than normal gas, but they do appear in regions with more gas because there are more UV photons. Some of these hydrocarbons are more highlighted in the galaxy than others. They expand out much further beyond the galaxy, but we don't know how these hydrocarbons got so above the plane of the galaxy, considering low star formation in NGC 5907, meaning there are no galactic winds to push the hydrocarbons up. Here are the sources, here are all the images again, and I have a Google Drive for my photos if you want to check that out.